This is about Honeycomb, which is not my project, but something I care about. The slides have been prepared by Maros. I will do my best to, talk about it. I will definitely express my private opinion about where I see value in Honeycomb and why we need things like management agents. And it's about the VPP management agent, the project within the FD.io. And Maros is a committer and the project technical lead using Linux Foundation Speak. In essence, what is Honeycomb? Honeycomb is a management agent providing two types of northbound interfaces at this stage, netconf and restconf. They both rely on the Yang payload. And so it's a model-driven approach to managing network devices. In this case, a virtual network device like VPP. And it's connected to the custom translation layer that basically accepts the edit config and the configuration requests and configuration reads from northbound, and also accepts the request for operational data. So both the writes and reads are supported. How does Honeycomb fit with VPP? Well, it's on top of VPP. And it's basically connecting to VPP over the binary APIs, the shared memory APIs, high performance, as described by Damian high level, and I think they will be covered in more detail later in the week by Ole or somebody else who knows about this much more than I do. And it's exposed to the northbound via netconf Yang and restconf Yang. Why is that important? Well, it's connecting the model-driven world to the not model-driven world, and also to be able to integrate quickly. Oh, we have a return path. Maros, you there?
Yeah, I'm finally here.
Okay, even louder than me. Very good.
Yeah, sorry.
So if I misspeak or misrepresent, please shout. So you can put any controller on top of speaking to Honeycomb that speaks netconf or restconf down. Open source controller like Open Daylight. Cisco has this software called NCS or NSO, same thing, or any other netconf, restconf based system. Honeycomb builds on Open Daylight components, but it is actually not an Open Daylight app. And Maros has been emphasizing this to me, quite a few times. So my ears got achy after that. So I got it now in my bloodstream. It's using a set of code modules and components from Open Daylight, so leveraging the work, but it's integrating them in a slightly different fashion, focusing on high performance programming of the virtual devices, or devices, in this case VPP. So it's what it's taking, the components it's taking from Open Daylight is Yang tools, MDSAL, the model-driven service abstraction layer, with the binding aware and binding independent code, basically representing the Yang structures into the local data tree, and then netconf and restconf server. The approach that the team took is a generic approach. So a lot of the code and the actual design is a generic design. The parts that are VPP API specific are modular, basically giving an opportunity for coders and committers to contribute the code on a per API type or API basis, and basically sort of circumventing the VPP specific path apart as a Honeycomb plugin, as shown on the slide. There are two main design functional components and design functional blocks. There is a data processing layer and translation layer. I think we're going to talk about this in a bit more detail on the following slides. The way that Honeycomb, which are the green bits, speaks to VPP is via the JVPP, which is part of VPP, and is basically using the low-level Java APIs. And the JVPP is auto-generated by the code that the team produced. So this is the functional diagram that I asked them to provide, and I think I can talk to some of it. I cannot talk to all of it. What matters for me is that there is a data broker with a data tree that separates the northbound from the actual part that interfaces with VPP. There is a data store, which means that in case of VPP crashes or Honeycomb crashes, that state is recovered, which is something that we do not have with VPP standalone today. With VPP crashes, you have to reprogram it. And it's got independent reader and writer paths. Writer for writing the config, and reader for reading the config. And I think it is shown on the following 2 slides in terms of the actual flows. The Honeycomb specific plugins, or sorry, the VPP specific plugins are isolated here as a bridge domain and in interfaces. So I understand that all of this code is a generic code. And Maros, correct me if I'm wrong, but the project has an ambition to, you do it like this to isolate the VPP specifics, but do you have any specific use cases that you're already looking at to utilize Honeycomb code for managing other devices?
Right. Okay, so we don't have any specific use cases except VPP that we would like to utilize Honeycomb for. However, while we were developing this, we realized that all of the code is pretty much generic. So we started developing it in that fashion so that in the future, when anything appears, we can reuse all there is in Honeycomb.
Data processing layer is really involved in handling the northbound interfaces, and also I understand is responsible for verification of the syntax and semantics as provided through the northbound against the young models that have been loaded onto the system, and the translation layer. So that's for the configuration. For the operational data, is basically the other way around. So the data is pulled from VPP. And it's translated into the Young models with config false option, if you're familiar with Young. This is a bit of the eye chart. It just shows the flow of the messaging. What is something that I like about netconf, and that's why I wear those t-shirts, is that netconf gives us currently the only standardized way to program in a disciplined and transaction-oriented fashion, two-phase commit, a large population of network devices. So this flow, as you can see, it's only after the information is propagated and committed and written to the VPP and accepted, is then the reply is being sent over to the northbound. So and that follows the basic principle of netconf that the commit is done only on OK and the rollback is on error. So this is done on a per device basis. If the error is sent back to the controller that's managing thousands of those devices, the rollback can be executed against those thousands of devices. So that drives the consistency not only through a single device, but also across the large population of devices. And this is a similar chart, but going through the netconf northbound data broker, operational data tree, and all the other bits to read the operational data from VPP. Whether it's an interface status, whether it is a tunnel status, whether it is counters, and providing this through the northbound RPC reply. What I understand translation layer does, it's really separation of readers and writers, as I already said, but it's really to provide the ability to create those readers and writers and the binding aware code on a per functionality group basis, and to isolate the main Young to non-Young translation engine. Maros, anything else to add here?
That's it, basically. It's extensible layer where you can plug in any readers, any writers. You can actually extend existing readers and writers also. And that's where the development for the plugins basically goes into or ties into.
Okay, so I think we have another slide that tries to explain on how easy it is to add new functionality when the VPP API exists. So I think let's maybe dwell on that slide next to talk about who you would like to pick from the audience to become a committer into Honeycomb. Adding features to Honeycomb. Apparently, it's very easy as long as the binary API exists. But as I stated in the earlier talk, the VPP dev community is quite responsive for functionality that's already there. Adding API is not a big deal, and they are happy to turn it around quite quickly, as I described with the show run API for telemetry. So make sure the VPP binary API exists, define the Young model, or pick up the model that already exists, whether it's IETF models or OpenConf. And then apparently the amount of code that you need to write to translate, to do the translation code between the Young and the API is not that much. So any representative data points, Maros, that you would have to illustrate how easy it is?
Right. So we still are lacking some tutorial samples and things like that. However, folks from Intel started developing something for us, and they have actually the code under review in Gerrit, and the same applies for Lisp functionality. Some folks from Cisco will pick that up. So at this point, you can actually work from examples, and those examples already exist and are developed by people other than me and our team, right? So that would be everything there is. You can also anytime consult us on the mailing lists, on IRC, on our weekly call, and places like that. We will be in the future, however, focusing on providing good tutorials, archetypes, stubs, and things like that to make the development much more easier for Honeycomb plugins.
The Java APIs are auto-generated using the VPP API as an input and smart Python code that the team developed. And it gives you access to basically everything that's available and exposed through the binary APIs. So let's quickly talk about current features. RESTconf, NetConf, fully supported. This is as per RFC 6020, yes? For NetConf, for RESTconf, I don't remember. So you can grill me on that. Both configuration and operational data are supported, and that's something that is music to my ears, because usually the operational data that is neglected. In SysIt, we are adding test cases. Some of them are already there for functional testing. And going forward, we have an ambition to actually also, on the ongoing continuous basis, test performance of the programmability and compare the programmability rates through the binary APIs with programmability rates of Honeycomb. So there is a bit of the policeman coming there. Maros, your way. And one other important thing, VPP crashes, Honeycomb crashes, or both are covered. And also Honeycomb already supports configuration rollback, correct?
It does, however, it's only experimental feature at this point. But the code is there, we need to test it, validate it, and we can then say that the rollbacks are.
Okay, well, knowing that you guys started only a few months ago, that's a bit faster to implement the configuration rollback than Cisco did with iOS and XR, right? It took quite a few years or decades, in fact. Okay, jokes aside, current features. So from the configuration perspective, that's what's currently supported. So real basics and different types of interfaces. And from the functionality perspective, bridge domain, from tunneling VXLAN. That's about it. But I think the hope is that you will be adding features now quite fast once as you are pretty much done with the infrastructure work, correct?
Right, that's actually true. We are finishing some of the infrastructure work. For example, we are still working on notification support for both NetConf and RESTconf. But from that point on, we will be focusing on new features and performance.
Okay, excellent. So I'm showing them what's next slide and notifications you mentioned. So this is the event-driven aspects of the system, and in terms of features, security features, Lisp for tunneling, NSH, VXLAN GP, routes management. Can you tell us a few words about the minimal distribution and how low you think you're gonna get in terms of memory footprint?
Right. Okay. So we are currently using the base distribution that is used for open daylight applications, and that's pretty big, and the footprint is also too high, right? So we would like to throw all that away. Don't use open daylight's base distribution. Don't use Karaf and OSGI, and actually don't use the config or wiring framework from open daylight. So that being said, we should size the footprint or lower the footprint pretty significantly. I would not like to talk about specific numbers, but should be compared to open daylight significantly lower.
Okay. I'll hold your word for it, and I'll keep asking you this question. Sorry for a surprise. It's something that we're trying to drive hard, lower the footprint. Are there any questions from the audience regarding the feature coverage and functionality?
Could we use Honeycomb, but not to configure VPP, but to configure Linux networking? Let's say configure VXLAN or routes, and why not some ACLs through Linux IP tables? And I know it may be some redundant task with what Open Daylight is doing, but just trying to understand the layering.
Can people consider using Honeycomb to program a Linux native networking stack, programming Linux networking stack, for example, IP tables?
Well, sure. I think it's not our primary focus, but it should work, right?
If which parts of the system would have to be touched to do that? Is it as shown on one of the other slides? The reading write part, I think it was on this slide. So the plugins.
Yeah, the plugins, and that's it. Plus you need to change the wiring, right? Because you need to wire the plugins into the translation layer. At the moment, that's a bit of XML that would have to be changed as well. But that should be it, I think.
Okay.
We are discussing southbound plugin between Honeycomb and VPP or Honeycomb and Linux, but my question is more like on the northbound, right? I mean, what I've seen from Honeycomb so far is kind of being like a child, let's say a child SDN agent from a mainline centralized SDN controller, and having some kind of northbound RESTconf or netconf connection or remote YANG mount, right, to the main data tree. My question is, when we run something more like a centralized control plane and we have a lot of state to download to VPP, for instance, then obviously, I mean, no, I don't know if it's that obvious, but the question is, what about the scalability of RESTconf and netconf? And do we have an alternate channel northbound from Honeycomb back to a centralized SDN controller? Let's say if we do centralized route computation and BGP, as opposed to embed the BGP stack in the Honeycomb distributed agent.
So the question is, Maros, about the scalability and performance of netconf specifically, a netconf server in Honeycomb to handle, I guess, bulk configuration, or?
I mean, our typical use case in Ericsson will be that we do route computation, we learn route with BGP and so on in the SDN controller, we compute the FIB in the SDN controller, and then we download that FIB, right. To the switches.
Yeah.
We used to do that with OpenFlow. Now with Honeycomb, we have to do that with netconf and whatever. What's the performance?
Very good question. So imagine the use case is a large volume route download. We have, as Damian has described, very performant and fast binary APIs, enabling you to program over 1 million of routes per second. If you look at the block stuff that I provided the data for, there are some also numbers taken from the machine on how fast it is. So any idea about Honeycomb performance for bulk route download? And if you agree or disagree that Honeycomb is the right tool for that, or if not, what are the tools?
Okay, right. So actually, we have a set of tests and benchmarks and performance numbers and also scale numbers for netconf, also RESTconf, and also BGP in open daylight, right? But specifically netconf, we already tested the performance and scale of open daylight controller talking to southbound devices using a netconf northbound server from open daylight. And I don't have the exact numbers, but we were able to get up to a couple 100,000. I think they were L2 FIBs actually pushed into an artificial device from open daylight. So the performance is pretty high. It can't compare with straight binary APIs at the moment, but the netconf servers should be pretty performant. And I think the numbers are publicly available. So if I can get to them, I will post them to anybody interested.
Okay.
And as for scale, well, we were testing one open daylight node controlling lots of southbound devices, and one node of open daylight with 4 or 8 gigs of RAM was able to control 10,000 or even more southbound devices using netconf at the moment.
Said 100,000 routes or whatever per right? Netconf
200,000, he said.
200 per second.
Yeah.
Okay, thank you.
But I think this is a very important point, and for any specific use cases, I would be also interested to talk to us. We should load the team with the actual real use cases. So thank you.
Right. So our end goal would be to provide all of the APIs, and we would like to actually encourage any developers who would like to help us, basically to help us with that, right? So we are a relatively small team, and we are focusing on the infrastructure for now. We are starting to focus on the features as well, but we would like to encourage anybody from FIDO projects or outside of them to help us with that. For example, if somebody will be developing a plugin for VPP, he should be able to easily provide the Honeycomb translation code to expose that functionality in Honeycomb, right? So that would be our ideal process of development. And at the end, we would like to cover everything. Right now, we are focusing on the features that we were told are more important at the moment.
So what is driving your priority of what is important, what is not? Use cases? What?
Yes, exactly. It's use cases. For example, the FDS use case from OpenNFV is our biggest use case at the moment. And their list of required features are our highest priority features that we are currently working on.
So it basically comes down to, correct me if I'm wrong, to the deployment use cases, which is exactly the mode of operation for SysID going forward. After doing the baseline in infrastructure, we really want to focus on developing things that people will use versus what marketing boys or somebody else will just ask, happens to ask the question. There is quite a few references and also how to join and contribute. So hopefully this makes sense, and please help.